Scientists may have detected radio emissions from a planet orbiting a star beyond our Sun for the first time. By monitoring the cosmos with a radio telescope array, an international team of scientists has detected the radio burst emanating from the constellation Boötes that could be the first radio emission collected from a planet beyond our solar system. Today we will discuss with you about the radio emissions that emanated from the constellation Boötes. Are they an evidence for an alien world? Welcome back to Signature's Life, and you're watching Signature's Science. The astronomers behind the new research used a radio telescope in the Netherlands to study 3 different stars known to host exoplanets. The researchers compared what they saw to observations of Jupiter diluted as if being seen from a star system dozens of light years away, and one star system stood out, Tau Boötes, which contains at least one exoplanet. The researchers developed the Borealis pipeline program to detect and study about the radio emissions from exoplanets. They tested it on Jupiter and then calculated what Jupiter's radio emissions would look like if it were much farther away. They decided to test the technique they developed using Netherlands' low-frequency area radio telescope, otherwise LOFERS, to look at 3 systems with known exoplanets: 55 Cancri, Epsilon Andromedae, and Tau Boötes. Only the Tau Boötes system, 51 light-years away, exhibited the peaks in radio data that fit the researchers' predictions from their test with Jupiter. It came in the form of 14 to 21 MHz bursty emissions and is within roughly 3 standard deviations of certainty. In 1996, a hot Jupiter exoplanet was discovered on a 3.3128-day orbit around the scorching young F-type star and the smaller red dwarf that make up the Tau Boötes binary system. The researchers are not quite sure that the radio emissions detected were coming from that planet. The researchers called for additional observations of the system, which is about 51 light-years away from the Earth in the constellation Boötes. The new research actually began at Jupiter. The researchers had previously studied that planet's radio emissions and then tweaked those measurements to reflect the effect they expected closeness to the host star and distance from Earth would have had on their observations of an exoplanet. In addition to the potential signal from Tau Boötes b, the researchers also report that they may have picked up a signal from the star Epsilon Andromedae or its planet. But that detection was even fainter than the one from Tau Boötes b. The researchers are interested in detecting radio emission from planets because such information may help scientists decipher what's happening in the same worlds. Magnetic fields. Those magnetic fields in turn influence conditions on the surface of the planet. Earth's magnetic field protects the atmosphere that makes the world one we can survive. For example, such magnetic fields can also tell scientists about other qualities of a world, like its structure and history. But so far, studying those magnetic fields directly has been difficult for scientists to manage, despite the fact that nearly every planet in our solar system has had one at some point in its history.